For number 12, we have something that looks similar to a quadratic. We can subtract 1 from both sides so that we can solve for 0. And we're going to make a trigonometric substitution here. So we are going to let y equal sine x. I'm not using x because it's weird to have the variable in sine x be x and then substitute it for x. It looks kind of weird, so I'm not going to do that. So what I have is 2y squared plus y minus 1 equals 0. And in fact, I can simplify by factoring this into 2y minus 1 times y plus 1 equals 0. So remember that 0 is a special number in the real numbers. It's the only one where if I have a product of two numbers that equals 0, one of them has to equal 0. So 2y minus 1 equals 0. Y plus 1 equals 0. This means y is 1/2, and this means that y is negative 1. But in fact, going back to remember that these actually had a value here that was sine x, we know that sine x equals 1/2, or sine x equals negative 1. So thinking about this, if sine x was 1/2, that's going to be here or here, and in fact, x is going to be pi over 6 plus 2 pi k, because the period of sine is 2 pi, or x is going to equal 5 pi over 6 plus 2 pi k. For sine x equals negative 1, we know that this only happens down here, so x must equal 3 pi over 2 plus 2 pi k. These are the general solutions for number 12. Now we'll move on to find our solutions in our interval. The interval that we're given is 0 to 2 pi. So in fact, in order to find these, we are only going to let k equal 0. Because if k equals anything more than that, we're adding 2 pi. So we get the answers of pi over 6, 5 pi over 6, and 3 pi over 2. We're now going to look at number 13 from the review. Can move this around. And what we're going to be solving is 2 cosine squared x plus 3 sine x equals 0. The important thing to note about this problem is that we're using both cosine and sine. That's going to be a problem when we try to factor. So we are going to change cosine squared into 1 minus sine squared x plus 3 sine x equals 0. 2 minus 2 sine squared x plus 3 sine x equals 0. I don't know about you, I really dislike that I have a negative in my coefficient here, so I'm going to just add or subtract everything from the other side. So I get 2 sine squared x minus 3 sine x minus 2 is equal to 0. And I can actually factor this as well. But in order to best see how I factor it, I'm going to let y equal sine x. Again, if you watch the video for number 13, I'm not using x because it's weird to have sine x and x equals that. It gets a little weird mathy-wise. So I'm going to rewrite this as 2y squared minus 3y minus 2 is equal to 0. And I can factor this to be 2y plus 1 times y minus 2. Remember, 0 is the only number that lets me do this. Y plus 1 must equal 0. Y minus 2 must equal 0. And in fact, this means y equals negative 1/2 and y equals 2. So to see where the sine of x equals -1/2, kind of on my unit circle, I know it's going to happen down here and down here. I know that using a positive rotation, this is 7 pi over 6, and this is 11 pi over 6. So I get 7 pi over 6 plus 2 pi k, and 11 pi over 6 plus 2 pi k. Remember that the period of the sine function is 2 pi. Now let's look at the other one. This is going to create a problem for us, because what this means, in essence, is that the sine of x equals 2. And we know that this is not possible, because we know that sine x has to be less than or equal to 1 or greater than or equal to -1, and 2 doesn't follow this. So this does not exist. Now let's look at part B, where we're asked to find our values on the interval from 0 to 2 pi. And in fact, just like in number 12, we need to let k equal 0. If k equals more than 0, we're adding a positive number to 2 pi. That's not going to work for us. So we get 7 pi over 6 and 11 pi over 6. Those are our two answers. This is working on number 14, the last question on the fall 2018 exam review. We're going to solve this equation here. 2 times the cosine of 3 theta minus pi over 4 is equal to -√3. I'll begin by dividing both sides by 2 so that I end up with the cosine of 3 theta minus pi over 4 is equal to -√3 over 2. So let's think about where this is going to happen. Cosine is negative in the quadrants 2 and quadrants 3. And in fact, I know that at 5 pi over 6 and 7 pi over 6 is where this is going to happen. So 5 pi over 6, and then down here is 7 pi over 6. So I know that 3 theta minus pi over 4, that thing I'm taking the cosine of, that has to equal 5 pi over 6 plus 2 pi k. And it has to equal 7 pi over 6 plus 2 pi k. But I need to solve for theta. So I will add pi over 4. So let's think about this. I'm going to kind of do this work over here. I need a common denominator, and the common denominator between 6 and 4 is 12. So I get 10 pi over 12 plus 3 pi over 12, which means that 3 theta must equal 13 pi over 12 plus 2 pi k. I'll do that same work similarly over here. Theta must equal, this 7 will become 14 pi over 12. And when I add 3 pi over 12 to that, I get 17 pi over 12 plus 2 pi k. Now I need to multiply everything by 1/3 in order to solve for just theta. So theta is going to be 13 pi over 36 plus 2/3 pi k. And here I'll get 17 pi over 36 plus 2/3 pi k. These are the two general solutions for this problem. And now we need to figure out what we can do to find all the values in our interval over here from -pi to pi, and see what we can do to find all of those. So we're going to go from -pi to pi, and we'll start with this one. So theta equals 13 over 36 pi plus 2/3 pi k. And then in blue, we will work out the values for theta equals 17 pi over 36 plus 2/3 pi k. So we can start by letting k be a -1. We found our common denominators. We are going to start with letting k equal -2. I've already done out the first one just so we can see how that works. I'll now work out the blue one. So theta is going to equal 17 pi over 36 minus 48 pi over 36, which should give us -31 pi over 36. Now we are going to let k equal -1. So 13 pi over 36 minus 24 pi over 36. And we will get -11 pi over 36. And for the blue one, 17 pi over 36 minus 24 pi over 36 should give us -7 pi over 36. We let k equal 0 just to get the ones that we found earlier, 13 pi over 36 and 17 pi over 36. Now we let k equal 1. So 13 pi over 36 plus 24 pi over 36 will actually give us 37 pi over 36. And I want you to notice this is bigger than pi, so this is not one of our solutions, which means that this other one also won't be one of our solutions, but we can show you just to check it. 17 pi over 36 plus 24 pi over 36 will give us 41 pi over 36, which is again bigger than pi. So this one's not a solution as well. So our solutions are -35 pi over 36, -31 pi over 36, -11 pi over 36, -7 pi over 36, 13 pi over 36, and 17 pi over 36. And that is the end of the review for fall of 2018 for exam 2.